quick review that Darwin had two big ideas. Number one, that living species, I guess the groups of organisms on the planet get more and more different the longer it's been since they had their common ancestor, descent with modification. Big idea number two, this one, that as long as you've got in a population genetic differences, overproduction, and competition, then you're going to see nature basically selecting by enabling the ones that have the good variations to survive, and more importantly, have a bunch of babies. They're going to pass those traits on to their babies. And what you're going to see over time is the helpful variations becoming more common in the population and the non-helpful ones becoming less common. That computes okay for everybody? The important distinctions here that are the most common things that students forget. First of all, individuals cannot evolve, right? This is not a matter of like, oh yeah, it got cold, so the bunnies grew more hair. No, it got cold, so the bunnies with less hair died. They already had less hair. The bunnies with more hair had more hair. They survived and had more babies and passed the more hair genes on to their kids. Does that make sense? I can't just evolve myself. It doesn't work that way, right? Evolution happens between generations. Evolution happens to population. The other distinction we want to make is this, that the natural selection phenomenon is the environment acting on, remember what phenotype means? Yes. Right? So like, it's cold, so the phenotype of those bunnies that you can see, which is their hair, how much hair they have, the coldness is acting on that, right? It's acting on the phenotype. But the change we're talking about, right? Mechanism acts on the phenotype, but the change itself, evolution, is happening under the hood. It's happening to the allele frequencies. It's happening to whatever gene controls rabbit hair. It's happening between generations as a change in how many of those rabbits have the long hair allele and how many of them have the short hair allele. That's the idea. We'll come back to those genetic changes in chapter 17 and start to actually see if we can measure them and talk about them in terms of the genetics knowledge you've got. But from here, we're going to take a little trip into evidence, because we have lots of ways of seeing how evolution has happened. Beyond the obvious, beyond the first thing you think of when you think of evolution, which is what? For evidence of evolution. What's the big body of evidence we've got? Huh? What were you saying, Armando? Yeah, I mean, sometimes living species can tell you things sort of about where they came from just by their similarities and stuff. But like a lot of this change has happened when we weren't anywhere close to alive, right? Like in prehistoric times. What evidence do we have of the evolution that happened then? Yeah, fossils. Yeah. So let's talk about fossils a little bit, and then we'll play with stuff. So one of the lines of evidence we've got is what we call the fossil record. We call it the fossil record, and what we mean by that is all the fossils that have ever been found and sort of added to the body of scientific knowledge. Because every fossil we find that's new teaches us. It's one of the fun things about evolutionary biology, especially paleontology, is we haven't found all the fossils yet. There's more. The fossil record, all those fossils that we found, they're a picture of what life was like. And the fact that we can sort of date them in several ways, relative dating and carbon dating and things like that, and know when they came from gives us a nice sense of what the different kind of ages of the Earth have looked like. Now, we haven't found all the fossils, but not only that, turns out you got to be pretty lucky to get fossilized. It doesn't happen to all the plants and animals that die. In fact, it's a really, really tiny percentage that actually get fossilized. So there's gaps in the fossil record that we have to fill in. You have to be in exactly the right place at exactly the right time to become the kind of fossil we normally think of. You have to basically get preserved for long enough that your hard parts, usually it's hard parts, so soft tissued animals almost never get fossilized. But if they have hard parts like bones or exoskeletons, they got to be preserved for long enough that the right minerals actually replace those bones or the spaces they leave, and it actually becomes something you can see. It doesn't happen that often. So there's gaps, right? But we do know several things. Number one, most of the species, and this sounds kind of grim, most of the species that have existed on Earth are extinct. But think about it for long enough, it's a very basic statement. I mean, obviously they are, right? Most of the people that have ever lived are dead. It's the same kind of statement, right? They have a finite lifespan, people do. Well, so do species, right? Species go extinct. And the Earth has been, harboring life for 3.7 billion years, give or take, 0.2 billion. And so, yeah, of course, most of the species that have existed are extinct now. But yeah, it's fun because we have to change. This is paleontology is a great test of our ability to do that T and tentative, to accept new information when it comes in, because new fossils get found all the time, and a lot of times they'll suggest something is different than we thought it was, and you'll see the same story played over and over where the older scientists are like, no, we know that's not true. Dinosaurs weren't more like birds than they were like lizards. Of course they're like lizards, and well, maybe not, right? And DNA evidence has upheld that, yeah, birds are basically what dinosaurs turned into, which is cool, I think. Like the fastest animal on Earth is a little dinosaur that flies through the air and preys on other little dinosaurs and fly like 200 miles an hour. Incredible. You know what animal that is? It's a peregrine falcon. I think is it 200 miles an hour? It's something ridiculous. Really. Yeah. That might be right. Yeah, and of course we knew that the continents just stayed in one place until somebody started finding fern fossils in Antarctica, right? Fossils really shake things up every once in a while. Finally, like I said, you got to be pretty lucky to get fossilized. Right place, right time.
Would it be easier to get like fossilized than another?
Oh, sure, yeah. Frozen living things are the best fossils. Well, tar pits are pretty good too. Yeah, no, the kind of traditional fossils are not, like I said, you only get hard parts on those. But every once in a while, we do get lucky with a line of fossil evidence that's almost perfect. Like, a lot of times we'll see like, okay, well, here's this version, and then here's this version a million years later, and here's this version. Then we got this big gap because there was no fossils, and we don't know what happened in this. But every once in a while, we get a nice line of fossils that just goes think, 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 and that's what you get to look at today. Grab a device, and we're going to look at horse evolution. Because the evolution of the horse, at least a good chunk of it, a good 50 million years of it, pretty clearly recorded in the fossil record. Yeah, hippus is Greek for horse. Okay, what you're gonna get here, dropped into Classroom, is a slideshow I've made for you. Kind of call it a horse scramble. Scrambled horses. Terrible breakfast. So here's what you get in the horse evolution scramble. You get a bunch of pictures of real fossils, but they're all mixed up. And so job one is to arrange them as best you can using traits that you see on them to where you think it's earliest to latest, right? So like the oldest fossils come first at the top, and you should end with what you think is the modern horse. Then at the end, you have 3 questions to address. Number 1, what are 3 characteristics you used to put them in that order? What about those 3 characteristics make you think the fossils go in that order? And then my favorite game, what good are they? I love taking a trait that is, because any trait started out as mutation and benefited the species and stuck around for a reason. So whatever traits you pick, why? Why do you think those gave an advantage? Specifically, one of the traits I want you to be focusing on, just kind of giving it away at the end here, is toes. Good? All right, I'll let you work. This is due tomorrow. Good luck.